Hello, everyone. Thank you so much for coming on, and thank you so much for accompanying us. And today we're gonna speak about CASPA. It's one of these projects which are very interesting, and the main reason why it's very interesting, and we're gonna learn more about it today, is that it's not necessarily a traditional blockchain. That sounds very weird considering we're only doing Web3 stuff here, right? But it's still Web3. It's slightly different than other blockchains in general, or, well, let's say Web3 projects out there. And today we're talking with Shai, one of the main researchers of CASPA. So, how are you doing, Shai? Do I actually pronounce your name correctly? Or maybe I'm absolutely butchering it?
Actually, you are botching it.
Oh, no.
Uh,
Oh, no.
my name is Shai, but
Shy.
it's fine.
Well, no, for now on, I would say shy.
Yes.
Like, I mean, it's good that you say so because if I would butcher your whole name, the whole space, that would be awful. So for now, I would say shy. So how are you doing? You
Hmm.
doing good?
Actually, I'm a bit under the weather, but I'm gonna do my best anyway.
Mm-hmm. Yeah. So obviously,
Uh,
I'm very excited for these Twitter Spaces, and you probably know that I'm very excited about it. So generally, we first introduce the guest, right? So I would love to learn more about you. How did you get in Web3? What did you do before Web3? Yeah, give us a bit of an introduction who you are.
well, I'm a PhD student. Hopefully, I will graduate in a few months. I'm into quantum cryptography and quantum computation in general. And accidentally stumbled into the crypto industry by teaching the same class as this guy called Jonathan Sompolinsky. It's how everything got started. Um, uh, I'm a mathematician, a computer scientist, a researcher, a bit of a coder, and this entire exposure and being hurled violently into the crypto space and into having people listening to what I have to say has been quite an adjustment over the last year or so. So I'm still surprised when people tell me they are honored to have me, but I'm also humbled. But this is pretty much who I am, I guess, in a nutshell. Did you get this? I think your mic is off.
Is it correct? I think I fixed it, right? Maybe something
Yeah,
went wrong.
now I can hear you.
Awesome. So it's interesting. I found your journey quite interesting. The reason why is often what you hear is that people were in Web2 finance, and that's how they get into Web3 finance, or generally how they get in Web3. And your perspective is from a wildly different angle, which is very interesting considering, I'm going to be very honest with you, we don't have, well, to be fair, to be frank, we didn't have any cryptographers so far on our spaces. So you are the first one to be here. And that's also why I'm quite excited about it, considering I'm quite sure the Twitter spaces will be done from a different angle, an angle which will be more technical. But let's try to break it down as much as possible. Considering,
Hmm.
yeah, cryptography is quite hard, isn't it? For people like me, it is hard. For you, probably it's a bit easier. You have a lot of experience there, but for me, still relatively hard. So let's begin with a very simple question about Caspa. Could you explain briefly the concept of Caspa for people which are not necessarily very familiar with it?
Okay, well, Caspa is a lot of things. I think the two things that make Caspa interesting is that it's a fairly large project. It's a community-driven project. It didn't start off this way, but it evolved this way. And this is the launch model we went with eventually. And it's a cutting-edge tech. Now, I know a lot of people say that the tech is cutting edge, but I maintain that ours is truly unique in the sense that it's the first to really solve the blockchain trilemma. And I think these two things are what makes Casper what it is. And I think because we actually bring something new and innovative that solves a really old problem, it allows us to garner a community with a lot of conviction, a really smart and educated community, and which interplays with the fact that we are fair launched and community driven. And I think the way these two things come together is what makes Casper what it is.
Yeah, it's interesting. Like we definitely gonna have a deep dive of some sorts in the tech. But you say it's also community driven. So what do you mean specifically with that? Considering, do you mean community driven that the community has large say within the ecosystem, or how generally? What does it actually mean?
I'd say it has all the say. The coin was, when I say it was fair lunch, I mean that there were no pre-allocations. Nobody got a cut of the coin, not the investors, not the developers, no one. Everyone just got what they managed to mine or to sell, which essentially means that the development is not funded by any reserve of coin that was put aside for that purpose. And this creates this very interesting dynamic where in a lot of projects, there is a portion of the coin that it's dedicated to development, and we don't have that. We rely on the community to pledge into development and into the funding of the development, and to um, provide us with more brain power. We garner and mentor developers from the community. And I think when I say it's community driven, the most important thing about it is that even though there is this set of people who were the first to develop this thing, um, the project is not theirs in any way. If they/we don't deliver, then the community would fund someone else.
I
So
see.
we have to keep proving ourselves, and we have to continuously earn the trust of the community.
I see. So that's like completely community driven, right? Because I agree with you. I mean, let's put this very basically here. Like most layer ones indeed have like venture capitals behind them, and they have most of the times indeed they have some sort of an ecosystem fund where they pay the developers or give grants to developers, and some of them have a team round which the team can basically get paid from. So that's interesting. So that means like you guys are basically being paid by the community in that case. I mean, and with you guys, I mean the developers, right?
Yes, to some extent, yes. Like the two major projects, the Rust rewrite and the implementation of GhostDog, were funded by the community, by community pools. I think the first was funded with the 70 million CASPA and the second with 100 million. I might be mixing them. And you see, if you go to our Discord, you'll see that there is a process. Many people can put up projects for vote and request the community for funding, either from the dev fund or by creating a new pool. And this is just how we operate. And there are people who contribute and do projects which were not a part of the original team, that they didn't work in Dag Labs, which was the company that originally developed Casper. This is
Understood.
how it works.
Understood. So actually, I've seen it. Like, obviously, I've been around with Casper for a few months now. And I, for example, had seen that you guys were pooling funds for a listing, for example, for a listing on
Mm-hmm.
an exchange. That's interesting. I found it very interesting. And to be fair, to be really fair, I was amazed that so many people were putting funds in there into this to get you guys listed. I was very amazed. I mean, to be really frank, you don't see that often in crypto. You don't see these sort of communities really. What you see is you have a community which is most of the times they don't really care about the project itself. They just care about price goes up, price goes down. So they're not willing to really pledge anything. But with Kaspa, it seems you guys are really structured a community, which is very cool to see. It's like it's refreshing to see, to be fair. And talking about the cutting edge tech, because obviously that is a statement, and I wanna know everything about it. So let's start with the basic concept, which is the block deck, which you guys use as the
Hmm.
main as your main architecture. Obviously, you guys sort of a iteration on that Ghost deck. We will come to that. Let's start with the black block deck. What does it actually mean, and what is it? Why is it different than a traditional blockchain?
Well, the only difference between a blockchain and a block DAG is that in a block DAG, a single block can point at several blocks, whereas in a blockchain, any block only points at another block. That's essentially the entire difference. The fact that it's a DAG in itself is meaningless. Like as Yoni likes to say, a DAG is not a solution. It's just the correct way to formulate the problem.
Mm-hmm.
And now that you have this structure, you need to ask yourself, okay, what am I doing with it? I'm telling people go mine blocks and let your blocks point to many other blocks. And now we have this structure, but why is it useful? So
Mm-hmm.
what's nice about a DAG is that if two blocks are created in parallel or several blocks are created in parallel, they are all included. It's not like in Bitcoin or Ethereum where you use some rule, either the heaviest chain rule or the ghost rule, to choose one chain and discard the other. All of the blocks participate. But this also creates a problem, right? Because if you have two blocks that aren't aware of each other, then both blocks can spend the same coin to different places. There could be a double spend. So
Mm-hmm.
the real difficulty in the DAG paradigm is how do you resolve such conflicts? And now both blocks are honest, right? You can't say one of them is bad and one of them is good. So you need to find some other way to choose which one of these two transactions is right. And choosing this rule, what we call the ordering rule, is what can make or break a block DAG. And Ghost DAG essentially is just an ordering rule. It's an algorithm which is given a DAG and produces a UTXO set or produces a chain, however you want to look at it. So that's what it does. And Ghost DAG is a very special protocol because it has the special property that its ordering converges very fast and is uh, is not amenable to attacks which usually arise when you try to work with DAGs, like liveness attacks or balance attacks. You can read about those. So essentially, there are several attempts, several other attacks that try to use this paradigm, but I think you could say that GhostDog is the first to, in a sense, get it right. To is able to produce this ordering without forcing the user to wait for a long time before they know the ordering will remain. So this what allows us to give these fast confirmation times, which is the key feature of GhostDog and of DAG
So, if I had to think about a sort of an analogy, you could say, well, a traditional blockchain is like building Lego blocks on top of each other, right? Like you keep stacking on them, like you keep stacking. Well, with block deck, so instead of you make a straight tower with blockchain, it's like you obviously with a normal blockchain you just make a straight tower. Like you every time you have a new block, you just put a block on it, right?
Knight.
And with block deck, you don't necessarily make a straight tower. You can have like they can branch out, right? Considering they don't necessarily have to be stacked on each other.
Yeah, I'd say that blockchains can also branch out, right? Because you could have two competing chains. You could have a fork. What
Sure,
DAGs can do and blockchains can't is fork back in. They can
sure.
reconverge. This
That's
is
a good
the
point.
point here.
Yeah, that's a really good point. That's actually a really good point. So assuming there won't be any fork, um, then the analogy is right. And if they fork indeed, well, the main difference indeed that can fork really back. Well, obviously,
Yeah, they can merge. You can take
exactly.
two chains and merge them back together. This is what Bitcoin can't do, for example.
Hmm. Hmm. And another thing you said about the special thing about GhostDeck is that it provides an ordering, right? Is that the K rule, which basically says, well, let's say the K should be 3, then you need at least 3 connections with other blocks, and if you don't have that sort of connection, so let's say you have a block which only have one connection, then by definition it won't take, well, it wouldn't be valid.
No, it's not. The K has a different role. Essentially, okay, you can think about it this way.
Mm-hmm.
You can say you look at the Bitcoin network or any blockchain network, and you have all of these forks, and it gets like the structure of a tree, right? There are some places where the chain splits into two chains, but it never merges back together. And what you do is you take all of the roots in this tree and you choose one, which is you consider it the correct chain, and you discard the rest. Sort of. That is what you do in Bitcoin. In Ethereum and other techs which use the Ghost protocol, it's a bit more complicated, but it's essentially is you essentially isolate a chain from the tree. And this chain is what we would call a zero cluster. It's like this K when K is equal to 0. And the idea in GhostDAG is that you allow blocks to be parallel, but you're saying, okay, say we have an attacker, which is like mining a separate chain or DAG or whatever structure, and in some sense, the block created by the attacker would be poorly connected to the rest of the blocks. So you're looking for this big subset of blocks with the property that it's highly connected. And when we say highly connected, we mean that for every block in the subset, there are at most k blocks in the subset which are parallel to it. Every block knows all of the other blocks except maybe k blocks. This is the role the k plays here. And we're saying, okay, if we allow the network to create one block a second, and we assume the network delay is, I don't know, around 10 seconds, then we'll set k equal around 10. Actually, you want to make it a little larger, around 18. And then you say, okay, we'll take the biggest set of blocks that we can find that that has this property that every block knows of all other blocks except maybe 18 blocks. And you call this the maximal K cluster, and you say these blocks definitely were produced by honest miners. They weren't produced as a part of a hidden 51% attack that was only published afterwards. And
That
if you
makes sense.
if you set this K to 0, you will almost recover Bitcoin. You will get something very similar to Bitcoin.
All right. So basically, what it means is you take the blocks which, or the set of blocks which has the most connections with each other, right? Considering then you say, well,
Yes.
that is the most likely the most valid ones, considering they have to connect most connections to begin with, right? Do I
Mm-hmm.
understand it correctly? All right. All
Yes.
right. So one of the criticism for DEX is that often they rely sort of on centralized features, right? So coordinators or pre-selected validators or witness nodes to mitigate some security risks. So basically, what they often there's like a security performance trade-off, or you could say rather security decentralization trade-off. Like
Mm-hmm.
how does Caspa solve these issues? Considering these issues are in some other DEC related um, protocols
I
they are
think
there. Mm-hmm.
I think I'd say that Casper just or GhostDAG came up with an ordering rule that doesn't have any of these problems. It just is a very good ordering rule. If you follow the Casper protocol, then provably, if honest miners are a majority of the network, then things are going to converge fast by themselves, automagically. I can go into the combinatorial aspects and explain what makes this works and what is the special sauce of the Ghost ordering. It's a mathematical argument and not a simple one. But at the bottom line, it just works. By using a very clever ordering rule, you get all the properties you want automatically just from the combinatorics of the problem.
Understood, understood. Like, even though I would love to go in mathematics, I think it will be quite complex. So let's try to skip that for now. Also considering the
Mm-hmm.
time, there's a lot of things I still want to talk about. And one thing you briefly mentioned was DAC Knight. So what is that? That's like, can you maybe explain what that is?
Well, I wouldn't go into the details of how it works. I'll just tell you what it achieves. So we say that GhostDAG has this very good confirmation times. Essentially, it's as fast as the network allows, but that's not quite the case. It has a parameter. You have to estimate in advance what is the maximal network latency. How long will it take the entire network to learn of a newly created block? And the thing is that you have to take this margin of error. If the network, if it takes 2 seconds, then you'd have to set this parameter to 10 seconds, because otherwise, if the network conditions degrade for some reason, then your protocol would become insecure. So this margin of error effectively means that your confirmation times are not as fast as they could have been, because you have to be cautious. Now, DAG Knight doesn't have this parameter. DAG Knight knows how to understand automatically by itself the network latency and adjust. So if the network conditions degrade, it would automatically descale itself to remain secure. And when they improve back, it would automatically rescale itself to be faster while remaining secure. So this is the great innovation here. You can actually operate as fast as the internet permits without taking any large security margins.
So if I understand correctly, what you're saying is whenever there are more users are coming in, currently it's hard to predict what the latency will be, right? And with DAC
Mhm.
Knight, it's more the latency is more easy to predict considering
With
the
DagNight, you
protocol
don't
allows it.
need to predict the
Cor-
latency.
like it,
DagNight reacts to changes in the latency by itself.
so the protocol basically adjusts itself, right?
It's self-scaling.
Understood. And so self-scaling in what sense? Because I could see like obviously whenever there are more users are coming in, wouldn't that lead like to congestion or some sort?
It depends on what you mean by users. We're essentially right now we're talking about miners, about how spread is the network of miners creating blocks. If you have many miners, then the networks become larger and might take longer for everyone to learn about new blocks. And now the scaling I'm talking about here now is not about throughputs, because throughputs are not affected by this. It's the scaling of the essentially of the K parameter I mentioned before, which governs on how long you would have to wait before you could safely assume a transaction is confirmed. And this is how DagKnight reacts. It knows how to change this parameter automatically to always be optimal and provide you with the best convergence.
But in that sense, obviously, whenever the transactions are quicker to finalize, wouldn't it also be more scalable in that sense?
Yes, this is what we're scaling here with DagKnight. DagKnight
Mm-hmm.
and GhostDAG don't have, they have the same throughputs. What's uh, what's nice about DagKnight is that it allows you to scale the confirmation times even better than GhostDAG. And GhostDAG already is the first tech to actually scale down confirmation times. If you look at other techs, you see that they take a minute or a minute and a half to confirm, because they must have long confirmation times to be secure. GhostDAG allows you to scale down the confirmation times to your bound, your a priori bound on network latency, which is a great achievement. And DagKnight takes it even further by saying we don't even need to estimate the network latency, we could understand it as we go automatically.
All right, that's very interesting. I mean, it provides definitely. I mean, to be fair, confirmation times of 1 minute that sound. I mean, just too long. I mean, it doesn't necessarily make a lot of
Mhm.
sense. Specifically, if you're gonna build like DeFi products or whatsoever, and you have to wait for 60 seconds. For some things, it
Yeah.
doesn't really matter, right? Like for GameFi, it doesn't really matter, probably not. But for DeFi and like complex financial products, it definitely matters.
Mhm.
Like
Now, I have to
definitely
point out,
matters.
just to be honest, when I'm talking about other techs, I'm talking about proof of work. text.
Mm-hmm.
Everything I say is about proof of work. Proof of stake is an entirely different paradigm, and it does manage to provide fast confirmation times, but it has other concessions and typically much more centralized.
Mm-hmm.
So everything, when I talk about the properties of GhostDAG with respect to other texts and other protocols, I always talk about proof of work. Proof of stake
Mm-hmm.
is a completely different discussion. I think proof of work and proof of stake are hardly even comparable.
I mean, I agree. I agree. I also agree that it will be a different discussion. It's also definitely a discussion which we can have another time, considering that's going to be a long one, probably, considering there's so much to talk about. But generally, I 100% agree with you. Proof of stake is generally more centralized, and therefore, obviously, whenever you are more centralized, scalability is much easier to
Mm-hmm.
achieve, generally. Um, Another feature I would love to talk about is pruning, right? Considering, well, let's address the elephant in the room here. There were some people, it seems like people don't really understand the concept of pruning yet in the cryptocurrency industry. So I would love
Yeah.
to talk about it, considering pruning is very important.
Mm-hmm.
A lot of people are like, well, why would you have that? Why is this the feature? So let's break it down very easy. What is pruning in a context of
Yeah, I
Caspa?
think uh, a lot of people have this common misconception that storing the entire ledger at all times is a feature. And I don't think that it is a feature more than a concession. It's just the way Bitcoin originally solved the problem. Now, storing the entire ledger on the every node, or there are light nodes for say Bitcoin, but to truly validate the chain, you need to have sufficiently many nodes that do have the entire thing. Um, and this is a problem because the longer the network operates, the larger the ledger becomes, right? So it requires more storage, it requires more hardware to validate all of the things. Syncing nodes becomes longer and longer. And there are a nice solutions for this, like Nipopos, but they are like partial solutions because you still have to have sufficiently many nodes that have the entire thing. And this causes a problem even for chains like Bitcoin or Ethereum, but when you increase throughput, when you talk about chains like Caspa, which can reach 3,000 transactions per second, then the rate of growth of the entire ledger, it's huge. It's like it comes to dozens of terabytes every year. And having to have all of the nodes on the network or many nodes of the network have this entire thing just to validate the chain, it becomes a huge hurdle for decentralization, right? Because how decentralized you are if to run a node, you need like 300 terabytes of SSD, right? It's not reasonable. So pruning is uh, pruning is the way that you can operate safely and have your chain remaining secure and verifiable, and you could verify its authenticity and its integrity without having to store the entire ledger. That's what it is. You only have to store a small amount of information, and that's enough. That's the meaning of pruning.
So it basically means that you I guess you delete it. You delete certain data which is not necessarily needed
Mm-hmm.
to validate the whole chain, right? So basically, you only store the actual important parts. Is that correct?
Yes, you have to store like the suffix of the ledger. Like if you think that you're never gonna see a split, like a reorg, which is more than 6 hours long, say, then you would like to keep at least 24 hours just to have this wide margin. And in our case, we keep 3 days for technical reasons. But you don't really need the block data before that. All you need is this small amount of headers, and it's enough. So essentially, a Caspa node doesn't need to keep the transaction data at all, except for the last few days.
And could you think of a scenario where one would need that specific data which is deleted? Is there any scenario where that could be an
Yeah,
issue?
I mean, and there is a solution for that as well. I'm gonna get into this. So I don't know, say that you want to keep track of how you moved your Casper around for tax reasons, for audit reasons, for yourself, and for some reason you need it to be authenticated. You need people to be able to cryptographically convince themselves that the data that you have really was on the blockchain at some point, that you didn't make stuff up. So this is a scenario. Now, I don't know if it actually happens because the way tax works in general, tax audits works, for example, is that you tell them what you did and they believe you, and if they find out that you're lying, you go to jail. But I don't know, maybe in the future cryptographically verifiable tax audits would be a thing. But there are other things you would want to do this for you. There are many reasons you would want to say this, to be able to prove that some information was on the blockchain, say, a year ago. And there are all sorts of benefits that people manage to extract from the necessity to hold the entire ledger history, right? And so you're feeling there is this kind of contrast. On one hand, you want this functionality, but on the other hand, you can't have it because it would make everything centralized and bloated, right?
Yeah, I mean, one of the reasons why you would need it, for example, is let's say the bank calls you because you
Mm-hmm.
cashed out some Bitcoin, right? And they say, "Hey, can you maybe give us some?" Well, let's say they cashed on some Caspa, not Bitcoin, Caspa. That's better.
Mm-hmm.
And they say, "Hey, could you maybe provide some proof?" And that is where the origin of the funds are. And obviously, that will be, well, with Ethereum, you just provide, or whatever, you can put any blockchain here, except for Caspa and maybe a few others, but let's say Bitcoin here. They say, hey, you can just send the TXD to the bank and say, here it is.
This space was downloaded via spacesdown.com. Visit to download your spaces today.
Good luck. But with Caspa, if it's after 3 days, it's not possible, right? So that how can, let's say I have to do that now. The bank called me before this Twitter Spaces, and I need the information as soon as possible. Is there any way for me to get that? Or yeah,
Well, if you need to get it retroactively, then no, you can't. You can't now find, like, I mean, in theory, say all of the nodes in the network are regular nodes. This is not quite the case, right? Because if you look at the Block Explorer, you will see that you can see transactions from a year ago. The thing is that the Block Explorer do stuff beyond what's needed for the consensus. They store this information because they think it might be interesting and useful to people. But the thing is that even if you don't want to rely on any nodes or anything like that, you can, if you do it in advance, while the data is not pruned yet, you can store what's called, you can keep what's called a proof of obligation. It's like this, you can provide the bank with the transaction along with a proof, a cryptographically verifiable proof that this transaction was included in the blockchain at the time you say that it was included.
understood. But that would only be possible within these 3 days, right? Because after the 3 days, it's gone.
No, it's only possible to store the proof within these 3 days. Again, assuming there aren't any centralized services that help you with it. But for now, in the most abstract sense, we're assuming everything that exists is just normal pruned nodes, then you have 3 days to store the proof. If you fail to do so, then you can't recover it. But the thing is that there are public block explorers that you can use. Some of the data has not been archived, data from the first days. We are working on trying to collect it back. But the thing is that I think the whole conception is that the responsibility for having a proof of publication, for being able to prove that this transaction was on the blockchain and it was accepted, it has to be shifted to the users, because when you're saying, I want all nodes to store the entire ledger, you're essentially saying it's the network's responsibility to keep proof of publications for anything, including data that nobody would ever want to use ever again. So the idea is to shift it, like it's your responsibility to keep your private keys. You would also have to, and it's not such a big deal, right? It would be easy to automatically implement, but your wallet will keep for you your transaction proofs of applications, like it stores your keys.
Yeah, I
And I
mean,
think if Kasper reaches this level of adoption, then there would be centralized services which actually do archive the entire network, and you could maybe pay them to provide you with proofs of publication for anything. But the thing is, it couldn't be like a free community provided service for long, because it's just gonna get more and more and more expensive to just maintain this database, right?
yeah, I feel like I feel like you make a few good points here. Like the first point, which I agree with, is um, putting the whole chain on a ledger is obviously going to be a huge burden
Mm-hmm.
for the community in this sense. And in the community, I mean specifically the miners, right? And if you really think
Mm-hmm.
about it, all right, what do you really solve? So what issue do you really solve? Well, the issue you solve in this case, with this imaginary scenario, is that people have access to all the data at any time. But then the question arises, how many times do you really need all the data on the ledger? Not many
Mm-hmm.
times. Most of the times, sure, it's nice to have. Right? It's nice to have, but it's always in a sort of a vacuum, right? You always have to see, right, what is the real trade-off? And the real trade-off is
Mm-hmm.
that the ledger is going to increase in storage size very, very quickly. And one thing I would
Mm-hmm.
like to emphasize here is, and obviously you already said it many, many times, but to maybe put it a bit in perspective, is if you let the ledger grow like quickly, so therefore you need more storage capabilities. In the Western world, it might be not as a big issue. Like people might be able to pay for whatever, but the Western
Mm-hmm.
world is not the majority of the population. Many people think it is, but it is not. Like the majority of population lives outside of this Western world. And obviously, you
Mm-hmm.
want to include them as well in the network. So if you increase storage capabilities in the sense of like quickly, then a lot of people might be not able to not only for storage capabilities, by the way, also like you said for sync, for example, because you have to
Mm-hmm.
download the whole chain, and if that's really big every time, like big blocks, whatever, they might be not able to download it in time until the next block is there, right? So
Mm-hmm.
that's obviously at some point you will come to a point where centralization will be a real thing, considering well only people really select amount of people will be able to be part of the part of the
Yes,
part of
and I do want to say a few words about what you can prove just from the data that is
sure.
available to nodes, right? Because maybe it sounds like anything that happened more than 3 days ago, you can't know anything about it. And that's not the case. For example, the balances are maintained. If I paid you some money and you didn't move it and it's available, then a year from now, all the nodes of the network will still know that you have a wallet with this amount of money. This information doesn't go away. Moreover, all nodes know exactly when I paid you this money. The UTXO itself contains this information. You can very easily find out just from the data in the nodes exactly when this payment was made. So there is a lot of useful information. You have the balances and you have the times these balances were created available for all of the balances in the network all of the time. And beside that, there is enough information to prove cryptographically that the network started from an empty UTXO set. I mean, the fact that there was no pre-mine is cryptographically verifiable. That we don't have the history doesn't mean that you can't verify that. And you can verify that the UTXO set evolved naturally. It wasn't tampered with at any point. No money was created along the way without anyone noticing. All of this is verifiable right now with the pruning. The only thing that it's pruned out is the transaction history and any transaction that doesn't lead to a UTXO. For example, if you want to prove that you received the money from me at a certain date, you can do it right now with a pruned node. You don't need anything else. If you want to prove that I'm the one who paid you, you want to prove for some reason what was the wallet that paid you this money, then for this you would need a proof of publication or an archival node, for example.
I understand. So to put an emphasis on this, because I agree, this is important. All the important data, which generally people would need to validate a chain, in this case, the block tag really, is there. Information which is not necessarily needed, like you said, well, would paid you, which wallet paid you, that is not there, right?
So the entire track that the money made from being mined all the way to your wallet, if you want to have records of this, you would have to keep them. Anyone who thinks these records are interesting, they would have to keep them. But you can't have the nodes of the network, their responsibility would have to keep this entire history for everyone forever, because that's just not scalable.
Gotcha. That's fair. Okay, right. And one question, which is possibly, even though you already kind of answered, but I would like to put an emphasis here, is it possible to hide any foul play by pruning data?
No, not really. I mean, think about it this way. If you try to foul play right now, then what do you mean by foul play? Maybe you can give me a concrete example of foul play.
For example, pre-mine.
Pre-mine.
Or speed mine.
So, okay, a speed mine is not, even if you had the entire ledger data, you couldn't prove there wasn't a speed mine, right? What information do you have there? You see money that was mined and went to all sorts of wallets. Now, you can't know which wallets belong to who. You don't know that even if you have the full ledger data. So how would that help you prove there wasn't a speed mine? Now, regarding a pre-mine, as I said, you can see that throughout that the network started from an empty UTXO set. So when the network launched, there wasn't anything suspicious. We also did this cool thing that the latest existing Bitcoin block was hardwired into the Genesis. So this rules out all sorts of timestamp manipulations. Like it rules out the possibility that we said that the network launched in November 2021, but we actually launched it a year earlier with a fake timestamp and mined all of this time. So the Bitcoin header, it's like a cryptographic version of taking a picture with today's newspaper. It rules out this option, for example. So I think one type of foul play that people might be worried about is like stealing money from someone else's balance, or like double spending and this kind of stuff. Now, if you try to do this today, then the miners of the network would note that your block is invalid, right? They would see that you are double spending or creating money that you should not be creating, or anything weird like that, right? So the mere fact that you have a decentralized network with many participants rules out your ability to do anything like that.
All right.
So,
I think you explained it quite well, and I totally agree with you that it's very interesting. It's an interesting feature, considering, like I said, it's different than other blockchains, but there's a good reason why this feature is here. And one thing I would love to also hear more about is that you guys are, if I understood it correctly, you guys also have a Rust implementation on Caspa currently, right? You guys did rewrite the client, I assume?
So one thing that's important to understand about Caspa, the unique property that I keep coming back to is that the throughput and the confirmation time and everything else is not governed by the security. If you take Bitcoin or Ethereum and crank it up to 100 blocks a second, then you just destroy the security, right? You will have tons of orphans, and because of that, the largest chain would not grow. Most of the work would go to the trash, and it would be very, very cheap to attack the network. That's essentially the problem, right? So in Caspa, this isn't the problem. In Caspa, you can increase the throughput as much as you want, and things would still be secure. So now it's reasonable to ask me, okay, so why don't you just have 10,000 blocks a second right now? Okay, you say that it would be secure, so why don't you do it? So the thing is that higher throughputs increase the hardware requirements. So we are in this unique position where we get to choose how expensive it should be to run a node, and then make the throughput as high as possible without exceeding these hardware or budget requirements. And now, if you have a much, much more efficient implementation, then you could run at much, much higher throughputs on the same hardware. That's essentially the definition of efficiency, right?
So it like you guys are trying to strike a balance between
Mm-hmm.
the scalability really and hardware requirements. Because obviously, if
Mm-hmm.
you're gonna put more blocks, you
I,
also
I
probably
I
need more.
would even I would put hardware requirements under decentralization. It's a part of decentralization.
Yeah, 100%. Considering obviously, whenever if your
Yeah.
hardware is very expensive to acquire, again, we come to the example which we had earlier. Only a really select amount of people will be
Yes.
able to buy it, right?
So yeah. So if we say, okay, we want it to cost $20,000 to run a Casper node, then yeah, I think we can go to 100 blocks a second. The thing of beauty here is that the Rust implementation is so much more efficient than the Golang implementation, that the network can run at 10 blocks per second, at 3,000 transactions per second on the layer one, right? No layer twos, no tricks, just on the layer one, 3,000 transactions per second, where nodes are running on hardware which costs like 100 or 150 bucks. That's the thing here. You want to have high throughputs on low hardware requirements.
So the reason to go from Golang to Rust was basically to make the client more efficient, right? To make it more
Yes.
efficient and that people more efficient because obviously, like you said, you can hire the hardware requirements and therefore also hire the scalability. I think it's the other way around, by the way, higher scalability and then higher hardware requirements. But obviously,
Mm-hmm.
then centralization will be a big issue. Eventually, it will. Like, sure, maybe now it won't be a big issue, but eventually it will, considering all these blocks, which obviously will stack up with more storage and all that. So that makes a lot of sense. And you say like 3,000 TPS is possible, right? With the new,
It's not only possible, it already happened. It happened on testnet, but it did
Mhm.
happen. We ran the
Awesome.
network for 3 days
Hmm.
on 3,000. It wasn't 3,000 TPS all the time, but it was for like several hours straight, 3,000 TPS. And that was just the first phase. During that phase, we identified many efficiency bottlenecks and things that we need to optimize. Now we are coordinating for the next phase after many improvements were introduced, and we hope to see 10 BPS running smoothly and requiring even less hardware, and then we might crank it up a bit more, maybe make larger blocks or increase the block throughput and see, maybe we can get to 400 or 4,000 or 5,000 TPS on a cheap hardware. We still need to see how far we can push this, but a preliminary result of 3,000 TPS, I think it's history, and no proof of work has managed to done anything close to this so far.
That's true. That is very true. And to be very frank here, I think 3,000 TPS is already a big achievement and probably more as enough for the time being. But
Mm-hmm.
obviously, if you can crank it up a bit more, crank it up, making it even more efficient. Obviously, that should
Yeah,
be
we
should be
want
the
to
goal.
see We want to see how far we can push it. Doesn't mean we should push it this far. I mean, maybe we find out that it can do 10,000 TPS, but it doesn't mean we should do it at this point. Right? Even if we find out that we can do 10,000 TPS, I imagine that the choice would be to increase the mainnet only to 3,000 TPS and know that we can go beyond that if that's ever needed. Just the fact that it's a choice and not a limitation, that's what's important here.
Exactly. I 100% agree with you. I mean, I think personally, I think if you have 3,000 TPS, but on the other side, if you can make it more efficient and you can scale it down, probably the side effect will be that the hardware requirements are also going to be lower, right? So that's also a really good thing, considering people will be, it's for more easy for people to come on. Considering the time, I also want to ask you a bit of a broad question, right? And this question I do ask for any project which is here, just to understand their perspective on the future of the protocol. So obviously, I always say this before I ask the question for the audience, take everything a bit with a grain of salt. Whenever we're going to speak about the future, things happen, right? So everything in the future is more about, well, these could happen, but we don't know yet. So what are the short-term and long-term goals for Caspa?
Yeah, I'm going to answer it in a second, but before that, may I just say another thing about the Rust implementation?
Sure, go ahead.
Yeah, okay, so I think one of the problems with the Golang implementation, that's the developing over it for developers who want to develop over Caspa is a bit hard because the API that's provided with this version is very, very limited. And we see it, for example, when we work with exchanges that it's very difficult for them to integrate Caspa into their exchange. Now, community-grown developers have taken this Herculean task of creating a brand new and much more powerful API in the Rust implementation will make this so much more easier to develop stuff over Caspa. And in his words, he said that things that used to take weeks will now take hours. So that's another major improvement that Rust provides, is that it has this very powerful API which will make it much easier for developers who wants to work over Caspa.
Oh, wow. Well, that's very interesting. But the thing which I love here, and that's very cool to hear, that it's made by the community, right?
Yes, I mean, the people who are working right now on Rust are a mixture of the people who originally worked in Dag Labs and were there from the start, and developers that grown from the community, and they made the way to learn the code base and contribute and become people who can actually extend the core of the Rust Caspa code base, which is very cool. And it's I consider it also a part of this decentralization. Like, you want to decentralize consensus, obviously. You want to decentralize the coin itself. You want it to be well spread. You want to decentralize node operations, so you want low hardware requirements, but you also want to decentralize knowledge. You don't want to have this select few people who are the only one that can develop the thing. You want to do as much as you can, so there would be as many people as possible that can contribute and extend and work on this thing. So this is like the broad message here, that we're working very hard to include people and to extend our ranks of developers.
Yeah, I agree. I think it's very cool, considering the community has a big say, even though like they can even contribute to the ecosystem, whereby with most other cryptocurrencies, that's quite hard. That could be quite hard at points, considering, well, they have a paid team. So yeah, if you want to be part of that team, you have to really come on and do an interview, I guess, and yeah, be there. Well, with Caspa, I guess it's much easier to contribute.
Yes, all you have to do is come on board and start working with us and see what you can do. And if you prove yourself as a coder, then you will be warmly accepted and become like our peer and our face value colleague. There aren't like people who are there. There aren't ranks. There isn't a hierarchy. They're just people who work together on an open source code base.
So in that sense, is it a bit like a DAO? Not necessarily a DAO, but like it seems like you guys are relatively decentralized. Like you said, there's no hierarchy, there's no real leadership. It's just people working
It's
together on
a
something, on like something
it's
like a. Mhm.
it's a social DAO. I mean, what makes it decentralized is not cryptography, but a social consensus. We are open to this, and we allow people to contribute, and we take contributions from just about anyone who writes quality code. So socially, we are like a DAO.
All right, that makes sense. It makes sense. Um, and so let's get back to the last question. So
Yes.
what do you have in mind? Well, not you necessarily, but the Caspa team, considering you were part of the Caspa team. What do you guys have in mind for the short term and long term? I think you already
Yeah.
obviously have spoken a bit about it with Dag Knight, but are there other things we can expect? Maybe things you are very excited about?
Yeah, I'm excited about everything. Short term, now I have to say this is only what I see. The thing is, this really is a community project. There is no CASPA team. There is the team working on this and the team working on this, and there are whole lots of stuff that people are doing that I'm not even aware of because there is so much going on. But from my point of view, the most exciting and most near-term thing is to keep pushing with the Rust updates and to keep seeing what kind of benchmarks and performance we could churn out of the system and to eventually increase the throughput in the mainnet and have a 10 bps mainnet or whatever it would be eventually. So this is like the short-term goal, and all of the other improvements like introducing this API, which will bring on more, I guess, um, developers over Casper, not developers of Casper, but we will see more apps and we will see more interesting stuff going on. Um, the more long term would be to implement Dag Knight, because this would be amazing. To see this thing go live would be, I think I would cry the day that this happens, because it's such an amazing protocol. And I already feel about current Casper implementing GhostDog that it's a work of art and intricacy that is unparalleled by most code bases out there, but Dag Knight is going to take it to another level. It's rocket science. And of course, in the longer run, where there aren't even any concrete plans yet, we want to talk about smart contracts and higher functionalities and breaching beyond the UTXO model and being a transactional layer. And the thing is that right now we are building an engine, and engines are important, but at some point you want to take this engine and put it inside a car. So I think the next logical step would be to pursue these kinds of directions, to see higher functionalities in one form or another, or in several forms at once. So this is like the horizon of where I think I would like to help take Caspa.
Yeah, sounds very interesting. I'm particularly interested, obviously, for Dag Knight and also for the smart contracts, obviously, because that will open a whole new world on Gaspa. Both of them, by the way. So these things I'm really excited about. And obviously, I do understand why you're very interested in the on the REST implementation. Considering, well, from a developer side, that's a really big thing, right? It changes a lot of
Mhm.
things. Um, and let's say I am a developer. Obviously, you already have spoken. You already said it's a bit, but I really want to emphasize this, considering if people want to contribute, where do they have to go? So let's say I'm a developer. I'm really excited about our her. Where can I start? Where can I start with Casper? What should I do?
You should come to the Discord, to the development channel, and introduce yourself. But you would also have to bear with us. We are very busy. We are a bit disorganized. You might have to reintroduce yourself many times and bug us a little bit. It's not because we don't appreciate the contribution. We appreciate anyone who wants to contribute. It's just because it's really hard. We do a lot of stuff all the time. But So you might have to exhibit a little persistency, but essentially what you have to do is just to come and introduce yourself and talk to us. I'm interested in this. I think I can do that. It could be you could come with your own initiative of what you want to do, and you could say, I want to contribute, say, to the Rust code base. Maybe give me an issue that is an easy entry level issue, or you might want to come up with a project of your own and then propose it to the community and try to have it funded independently from the dev fund or from a funding pool. People do all of these things. So it really depends on what you want to do, but I think the first thing you should just come over to Discord and say, hi, I'm a developer and I want to contribute. I like this and I like that, and I thought about this and that. What are my options? We don't have this rigid structure. As you said, we aren't a company. We don't expect anyone to send us CVs, and we won't take anyone to an interview. Just come and make an acquaintance, and we'll see how things roll from there. But just we will welcome anyone who wants to participate.
Understood. And what if I'm not a developer, but I still want to contribute? Is there any way for me to contribute in that case?
Anything you see that's related to Caspa in any way, which is not writing code or writing papers, came from the community and most of the ecosystem as well. A lot of stuff is people just done stuff on their own initiative. Like there is the Cas FYI block explorer. This guy just decided he wants to write a block explorer, and so he did. You don't even need our permission for this because it's a permissionless network. We don't. If you want to create a block explorer right now, there is nothing we can do to stop you. We wouldn't want to stop you, but the point is that you can just go on your own initiative and do it. And people are creating information websites and YouTube channels and merchandise, and people are making contacts and making sure that people hear of us. Now, we do have some sort of an ambassador program. I don't know much about it, but if people want to contribute this way by spreading awareness, they should also. Okay, maybe I should say this way. If you want to contribute to Caspa in any way, the first thing you should do is come to the Discord and introduce yourself. But I'm saying any sort of help is welcome. If it's all the range from making funny memes to writing academic papers and anything in between, there's room for that. You just need to show initiative, and the way will be found.
Understood. For my part, there are no questions anymore, but let's see if there's a few questions from the community. If you have a question, you can open up. Well, actually, you should request to be a speaker, and I will grant you to talk with us and ask a question. Please be polite and civil. I already have one question from the community, and that's about what path will be followed for marketing, advertising, and collaboration? So it's more a bit of a marketing question. Do you have any answer on that?
Well, my answer is that we have people also community grown that do marketing. I don't know anything about the marketing aspect. I can tell you that they're doing a great job because this entire, the logo, the brand, the colors, like the fact that we have a signature color, it's all thing these people done. Like this guy, Barbarian, I think he's the first professional marketer or designer. I don't know even the correct term that really took us under the wing. But there are people who know how to do this and understand marketing and public relations, and they are really the people you should ask. I am beneath all of this crazy thing that's going on that is the Caspa project. I'm just a mathematician. I don't really know anything about marketing or PR.
No, that is fine. Let's go back to the tech in that case. So another question we have is there a possible integration of smart contract with Cosmos or Cosmos WASM on Rust?
I actually don't know. Again, this is not my forte. I don't know much about Cosmos. I think again, these kind of questions about like particular texts and particular integrations with other projects, I am not the correct address. I do like research, I do theory, and I haven't written a single line of code in the entire Caspa code base.
I mean, you're doing a definitely great job with researching. I love all the papers you guys are putting out. I love them. So that's a really big shout out to you. I really, really love them. You guys doing a great
Thanks.
job in that sense. Um, I don't think there are any more questions. I see that a lot of people are very happy with how you did explain things. So on that card, I already give you a great job. But before
Thanks.
we go, I would love to give you the last note here. So if there's anything you might want to put up emphasis on, or maybe I didn't ask you a certain question and you would love to talk about it, this is your chance. Yeah, so the floor is yours.
Yeah, whenever I get the floor, I do the same thing. I just shout out to the community. The Casper community is amazing. I think it's a highly intelligent community. I just love seeing how people are thirsty for knowledge, how people really take the effort and time to understand what I'm saying, just not just echo and repeat it. People constantly challenge us and ask us questions, and really it's important for a lot of people to really understand what's going on. I think this is our strength. So really just a shout out for the community. It's just so amazingly empowering to see so many people that much interested in what we do and in what I do. So just thank you.
I mean, that is very cool. I love that. Considering you guys are a community-driven project, and to see that you have so much admiring for the community, that's awesome. And on that note, I think it's the perfect note to also close this Twitter Spaces. I would love to thank you for coming on. I really, really appreciate it. Considering, like you
Thank
said,
you for having me.
yeah, but like you said, you are quite busy. You guys are very busy, so obviously this is still a valuable time for you. So I thank you so much for coming on, but also for the audience. Thank you so much for listening to us for over an hour. And it has been technical at points. If you have questions, feel free to put them down in this in the comment section of this Twitter space, and we will definitely come back to you. And on that regard, I would like to thank you all for coming on, and I wish all of you a great weekend. Bye bye, guys.
Bye bye.